Well, hello Internet, and welcome to my Erlang video tutorial. In this one tutorial, I'm going to cover the core syntax of the Erlang language through a ton of example code. Now, this is the #1 most requested next all-in-one video you guys asked for, and so here it is. Like always, all of the code as well as a cheat sheet for this entire video and also timestamps to all the different parts of the video are available in the description. And this video is basically for somebody that already knows another programming language and wants to learn how to do in Erlang what they do in other languages like Python or Java or C# or whatever they're used to. So I'm going to be doing a lot of unconventional things, but I think you'll learn a lot about Erlang in this video, and I have a lot to do, so let's get into it. Okay, so I made a previous video, which is also in the description, that shows you how to set up Erlang, install everything, and get it to work with Eclipse as well on a Macintosh and on a Windows computer. So this is what we're going to start off. We're going to come over here to Source, and we're going to go New Module. And we're going to open this guy up, and I'm going to call this tut.erl. That is the extension for an Erlang file. Then I'm going to click on Finish, and it's going to spit all kinds of crazy stuff all over the screen. Now, basically, modules are going to contain many different functions. And this guy right here is always going to be the first statement in any of your Erlang files. We are probably going to also want to import a whole bunch of different things here. So the next thing I'm going to put inside of here is import. And I'm going to import a whole bunch of string functions that I'm going to cover later on. So we'll have length, and the way you set this up is you are going to define the function's name. So this is length. It gives you the length of the string. And then you're going to follow that up with the number of attributes that that function is going to be receiving. Concat, likewise, is going to allow you to join two strings, and it's going to receive both of those strings as attributes. And there you can see a whole bunch of other different functions, which as the tutorial continues, I will cover. Then you're also going to have to then put export inside of here. And this is going to be where you're going to find what functions can be called from this module, your personal module. And to start off, I'm just going to put in hello world. I'm going to keep this very simple. And don't worry, I'm going to get into all kinds of complicated stuff. So this is not going to receive any attribute, and that is going to be the end of that file. Also remember to always end these statements with a period like that, and likewise like that. And now what we're going to do is actually go and create a function inside of here, and this is the hello world function that I just previously mentioned. Put the parentheses at the end, and then you're going to put this little arrow inside of here. You're going to then tab in, and here all this guy is going to do is go and print some information out on our screen. And you may have guessed it, but it's going to print out hello world on the screen. All right, and this is a new line, which just means it's going to put a new line after it prints hello world on the screen for us. Then we can come in and we can save that. Then we're going to come up here. This is Eclipse I'm using, and we're going to run this guy. And you're going to see the console changed a little bit. Over inside of here, I'm then going to change to the directory where I have all of my files. You can see that right here, Erlang, Tut, and Source. It's going to be different for you unless you have a Derek Banis directory. And if you do, you're very awesome. And we're going to hit enter inside of there. And then to execute this guy, we're going to come over here and we're going to go, well, first off, we have to compile it. So we're going to go C, put tut inside of there, which is the name of our file, right like this. And then we can come in here and go tut like that, and main, and then and hello world with our parentheses, and then period. And we run that, and you can see hello world comes up there. All right, so pretty simple stuff. Don't worry, we're going to get it much more complicated than that. Let's come in here and also define that we want to export another function. And you may have noticed that all your functions are going to be lowercase letters. And this guy is going to add two values. So I'm going to put add inside of there. And then obviously it's going to add two of them. So I'm going to put that inside of there. Now what I can do is come in here and define my function. And it's also interesting to know that you're going to be able to call other functions from inside of your functions. So we're going to go hello world like this. And then we're going to put a comma at the end of that. And that's going to allow us to call the hello world function. And then we're also going to be able to come in here and add these two values that are passed inside of here. So we're going to save that. We're going to go tut. We are going to go add. And then inside of here, we can go 5 and 4, whatever we want to do. Hit enter. You can see that it printed out the hello world because it called that function. And it also went and got our result and printed that out on the screen. So you can use fwrite or a whole bunch of other different ways of outputting to the screen, or you can just come in here and just have whatever you want to show up on the screen, just put that right in there and it just works. It's also interesting to know that we are going to be able to come in and define functions with the same name that are just going to have a different number of attributes. So let's say we also wanted to be able to add multiple numbers, 3 numbers for example, we could do so. So let's just copy this. Paste that inside of there, and we'll go C like this, and then we will go A plus B plus C. And we can save that, and tut, and add, and then we can say something like 3, 4, and 5, and close that off. And you're going to see it did the hello world, but it also now allowed us to add in 3 numbers instead of just 2. Another thing that's kind of interesting is you can get some information about your module just by going tut like that, and tut's the name of my file here, and just go module info and dot, and it's going to provide you all kinds of information in regards to the different modules that you have inside here, or different functions you have, and a whole bunch of other different things, which I'm not going to get into here right now. And now, only to save time and keep things a little bit constrained here, I'm only going to export one function, and it's going to be main, and the main function isn't going to receive any attributes, so I'm going to put a 0 inside of there. Now, Erlang normally doesn't work this way in regards to using a main function or whatever. I'm just doing this to try to keep everything well organized so I can cover it. So I'm going to do inside of my main function, just go main, and then like this. And I'm going to call a function that's going to be called variable stuff. Well, make sure this is indented, variable stuff, and put a dot at the end of that. Now, variable names are going to start with an uppercase letter or an underscore, and then they can contain either letters, both uppercase and lowercase, numbers, underscores, or @ symbols. And it's very important to understand with Erlang that variable values cannot change. However, variable types are going to be defined dynamically. So the type is going to be defined based off of the type of data that you try to store inside of it. And another thing that's interesting to point out here is that you are going to be able to call a function inside of here before it's actually been defined. And that just means that I can come down here and put variable stuff up here or down here below where it was actually defined. And all this guy is going to do, it's just going to be a function that is going to define a variable, remember uppercase letters, and commas if you want to have multiple different lines inside of here. And then this is just going to return the value of num, right like that. And then we can come over here, oops, make sure I save this first, save it. Now, because we changed the function we're going to export, we're going to have to come over here and compile this. So C tut like that. And now what we're going to be able to do is just go tut and main and run it. And you're going to see that the 1 comes out right there. Now, an atom is another variable that's name is actually going to be equal to its value. And they're all going to start with lowercase letters. And they can either just be a simple word, starts with a lowercase letter obviously, or they're going to be surrounded with single quotes. So I'm going to change this to atom stuff, and I'm going to change this to atom stuff like this. And then I could just simply come in here and do something like an atom like that, and run that over there, and you can see an atom comes up inside of there. Or I can come in here and just put a single quote and go an atom. If there's spaces inside of there, obviously you're going to have to use quotes. And there you can see an atom popped up. And if you're missing it, you have to go in here and type tut main like that, and followed by a period, and that is going to execute your code over here on the right side of the screen. Now I want to do some math things here, just to cover a couple other different things. So let's go call this do math. And let's have this function come in here and pass 5 and 4 inside of there. And I'm going to call this do math, and it's going to receive 2 attributes, obviously. And let's have it come in here and just add these values. So we'll go A plus B like that. And you can see that 9 comes back, so that works great. We can just throw a comma inside of here. We could also go in and go A minus B, put that period inside of there, and run that to get an answer of 1. We could also do multiplication, of course, and division, and you can see there that that is floating point division. You're also going to have an option to do just integer division. In that situation, you put a div inside of there like that, and then we'll come over here and run it, and you can see that only 1 comes back. And we're also going to be able to do modulus, which is going to return the remainder of a division, and we can run that as well, and you can see 1 comes back from that. There's a whole bunch of other different specific math libraries involved in here also, or available also. So let's say we wanted to go and get e raised to the x power. We could do so. Let's go put exp inside of here, and let's just do 1 like that. And there you can see is the value of e. We're also going to be able to come in and do the natural logarithm. So we can come in, well, we just copy e here, copy that, and change this to log, and paste e inside of there, and run that guy. We're also going to have the common log. Let's throw a 1000 inside of there and execute that for 3. We're going to be able to take, let's say, 10 to the second power by just putting pow inside of there like that, and 10 to the second power, and there's 100. We also have square root. So square root, and let's just change this to 100, and there's 10. And you're also going to have all of these other different functions you have right here. Of course, you're going to put math in front of them like we did here to be able to use them. And if I didn't mention it before, if you want to put a comment, you just put a %sign inside of there, and everything after that is going to be completely ignored. If you'd also like to know how to generate a random value, you can just come in and go random uniform, and let's say that we want to generate a random value between 1 and 10. That's how that's done, and there it is. You can see we got 5 like that, and then each time we call it, we're going to get different values. There's 8 and there's 10. And now I want to talk a little bit about how we can compare values. So I'm going to come up inside of here in this main area, and I'm going to say compare, and I'm going to put a 4 inside of here and a 4.0. Change this to compare, leave A and B in there. Now you can check for equality of both a value and type by just going A and an equal sign with a colon inside of there, and B, and you can see that false comes back from that. You're going to be able to check for inequality between them, both in value and type. That's what I'm checking here right now, and you can see that comes back as true. You can also check for equality and disregard type. See, this is a floating point and this is an integer. Here we're not going to pay any attention to type, and you can see that comes back as true. And you can also disregard type for not equal to by putting that guy inside of there. Another thing that we'll be able to do is you're also going to be able to go greater than or less than, greater than or equal to. This guy's a little bit weird. This is going to be less than or equal to. And you're also going to have the logical operators, which are going to be and, or, not, and exclusive or. And I'll come in here and do a quick example here to show you what's up with this. So let's say you have age is equal to 18. Put a comma inside of there. And then we can do some comparisons. We can say if age is greater than or equal to 5, or age is less than or equal to or less than, maybe we should say, 18, then we're going to come back here and get a result and put that inside of there, and you can see the true comes back. All right, so there is a rundown. You can test, the other different logical operators, but I think you get a good idea of how comparisons work. So now I'd like to talk about if conditionals. Okay, so in the main section, I'm going to create a function called whatGrade, and I'm going to throw 10 inside of here. Now down inside of here, I'm going to create 2 functions, and one of them is going to be called preschool, and it's not going to receive anything, but whenever it's called, it is going to return go to preschool. And then we're going to create another one, and it's going to be called kindergarten. And whenever it is going to be called, it instead is going to say go to kindergarten. Okay, 2 very simple functions. Going to create another function, and it's going to be called grade school. And this one's going to be go to grade school. All right, so we got all of those different functions set up. Now we're going to actually come in and create whatGrade. So I'm going to go whatGrade. And I'm going to receive a value passed inside of here. As you can see, I'm not defining data types or anything. And then here is an if statement. So I'm going to say if x is less than 5. In that situation, I want to call the preschool function. Go down to the next line. Then I'm going to put a semicolon. Then I'm going to go x equal to 5. In that situation, I want to call kindergarten. Come down to the next line, put another semicolon, and then I'm going to say if x is greater than 5, in that situation, I'm going to say grade school. Okay. And then to end off this if statement, we're going to put end and then a period. We can come over here and execute this guy. And there you can see that go to grade school pops back exactly like we would have guessed. So there's a rough overview of how we can work with if, and I know else isn't inside of there, but you can see the basic structure of how we can do all of those different things using Erlang. Now I'd like to come in here and now talk about case conditionals. So I'm going to come in and change this to say hello is going to be the name of the function. So say hello, and inside of it, I'm going to pass an atom that is going to be German, and then define the function. So say hello, and then based off of what they pass in, they're going to get different results. So I'm going to say case x of, and if it has the value of French in that situation, I'm going to return bonjour, throw in a semicolon. Otherwise, if they go and put German inside of there, I'm going to go Guten Tag, close that off with another semicolon. And if they say English, in this situation, I'll go hello. Okay, so depending upon what is passed inside of it, that is going to change the results. And then we're going to end that case, and we are going to run this guy. And there you can see Guten Tag pops back, just like you would have thought. All right, so just a real quick explanation of how case works. Go in there and experiment more with it to figure out some other neat things. And now I'm going to talk about strings in pretty much a little bit more depth. So the function I'm going to use this time is going to be called string stuff, and it is not going to be passed anything. And then I'm going to come in here and create string stuff. So string stuff, and basically strings are going to be surrounded by double quotes, and you're of course going to use an uppercase letter to start this off. And we'll go random string and throw a comma at the end of this. We'll go and create another one. We'll call this string 2. And this is going to have the name of another string. Throw another comma in there. And you can put spaces and things wherever you would like to do. And now you're going to be able to place these strings or any data inside of your output using a tilde, and I use P. It's up to you, whatever you want to use. So we go fwrite, and let's say I want to do something like string, and I can go tilde P and tilde P and throw in a new line inside of there. And then to transpose those in there, you're inside of brackets, you're going to go string 1 and string 2. And they're going to show up in the output based off of the order. So this is going to go to the first one, and this is going to go to the second one. And you can see if I ran it, it's going to show random string, and then it's going to show another string. Okay, let's continue doing some more. You're also going to be able to use format for similar results. So let's create another string here. And so we'll go IO, lib, and format. And here I'm going to say it's a, say I'm just going to go tilde S and tilde S, throw in a new line inside of there, and then go string 1 and string 2. Close that off. And now I'm going to output it on the screen by going IO and fwrite, string 3, and then close that off. And then you can see it says it's a random string and another string. And you can also see in this situation, we don't have the quotes around the strings that we were importing, which might look a little bit better. Let's go and do some more. If we wanted to output on the screen the string length, we could do so. Let's go string length like that. And you can see 15 pops back right there. Do some more. There's a whole bunch of these guys. I told you before you can concatenate strings or join strings together. We can go string 4 is equal to, and we'll go concat and string 1 and string 2. And then I'll go string 4 like that, main. And you can see random string and another string comes back there together. Of course, there's no space. Continue adding some more things. You could also get the index for a character you're searching for. So I'll call this character index. And to do so, use the function chr. And if you're not remembering, this is where all these functions were defined up here. Okay. So I'm going to go string 4. And then you're going to put a $sign and then the string that you were specifically looking for inside of there. And I can go character index and execute that. And you can see it shows up in the third spot, which is this. Okay. Likewise, you're going to be able to get a substring of a string by defining the starting index where you want to start, and then the number of characters thereafter you'd like to receive. So let's go and call this string 5, and this is substring. And you can go string 4, And let's say I want to start at the 8 index, and then I want to get 6 letters there afterwards, or 6 whatever characters. And then let's output that on the screen. And there we go. And there you can see string pops back. You're also going to be able to get the index of a string. So let's call this string index, like that. And we go string, and what we're going to be searching for is string 4. And what we're specifically looking for is string 2. And get our string index. And there that is, shows up at 14. And for the final 2 examples of things you can do with strings, let's say we also wanted to do uppercase. We wanted to uppercase every single one of those characters. We can do that. And random string pops up. And then we're also going to be able to likewise go to lower. And there you can see everything's lowercase. All right, so there's a rundown of a lot of things you can do with strings inside of Erlang. And now I'm going to talk about tuples. Now a tuple is going to be able to hold multiple values. So what we're going to do here is define another function. I'm going to call this tuple stuff, and I'm going to define a tuple. So let's just call this my data, and you're going to put this between curly brackets. So I'm going to put 42, 175, and 6.25, and you can use different types of data as well. And then we can come in here and get the data just by going my data, and you can see it output there on the screen. You're also going to be able to store values inside of another tuple. So we can come in here and go something like A, B, and C, and then reference our tuple here, and then output the value of C in this situation. And you can see 6.25 shoots back there. You're also going to be able to use what are called anonymous variables to match a pattern. Let's just come in here and do another one of these. An anonymous variable basically is an underscore. So you're going to put, if you don't care about something, you don't want the data back, just put those underscores inside of there. And there's my data. And then here we can output the value of D. And you can see 42 pop back. You're also going to be able to use an atom as the key for a value. And this is what we call a tagged tuple. So let's go my data 2 equal to, and we can put height inside of here, which is the atom, and then 6.25. And then after that, we could go height, and let's just call this HT is equal to, and my data 2, and then output the height on the screen. And there you go. All right, so there's some things we can do with tuples. And now I'm going to look at lists. So I put list stuff inside of there, and there's list stuff. And basically, lists are going to contain multiple values from any data type. So let's go and define a list. List 1 is equal to 1, 2, and 3. And let's define another one. List 2 is equal to 4, 5, and 6. Now you're going to be able to join lists. So let's go and create another list, list 3. And you can do that just by using the ++ sign. And there's list 2. And let's go and output list 3 here on the screen. And there you can see, join those together. You're also going to be able to subtract a list from a list. So we can go list 3 with just putting minus minus and subtract everything that was in list 1 out of that guy. And then we can output list 4 here on the screen instead. So there that is, and there we go. You're also going to be able to retrieve elements. And in this situation, what I want to receive is the head or the first element inside of our list. So we'll go list 4. Likewise, you'll be able to receive the tail by going TL, and we'll do that for list 4 as well. Here we can just execute that guy. And there you can see it grabbed it. The 4 would have come back for the head, and the 5 and 6 come back for the tail. And you're going to be doing a lot of things like that using Erlang. You're also going to be able to add a value to a list using something called the cons operator. So I'm going to go list 5 is equal to, and I'm going to go 3, and then list 4 like that. And then if we output list 5 on the screen, you can see that 3 is now in there in the top position inside of the list. And then finally, you're going to be able to get the head and the tail from a list. And like I said, you'll be doing a lot of this later on. So we'll go head and tail is equal to list 5. And in this situation, I'll just get the head and I'll put that. And there you can see 3 pops back. Okay, so a whole bunch of things we can do with lists. Now let's go and take a look at something more interesting, which is list comprehensions. So I'm calling this guy LC stuff for list comprehensions. Now list comprehensions are going to make it very easy for us to manipulate lists. So let's go and create a list to go and show you an example of that. So let's just have 1, 2, and 3 inside of this guy. And let's say we want to multiply every list item by 2. It's pretty easy to do. We can just go list2 is equal to, and then we're going to define what operation we want to perform. Put 2 of those pipes inside of there. And then we're going to define the temporary name for each list item that's going to be pulled out of the list one by one. And we grab that like that. And then we can output the new results that we have here. And there you can see it went and multiplied all those by 2. Okay, so we do even cooler things. Let's say that we would like to come in here and add conditions. Like for example, we want to get a list and we only want the even values from it. Let's go and create list 3 and just 1, 2, 3, and 4. And then we'll go and create list 4, which is going to be nothing but my evens. I can go in, put those 2 pipes in there, and then in. And then we're going to be pulling this out of list 3. And then we can define our conditions. So we'll say n, remainder of a division using 2. If that comes back out as equal to 0, well, then we know it's an even value. And then we can come in here and output the list itself. And there you can see it grabbed only the even values. Okay. We're also going to be able to do things like search through a list of tuples. So let's say we want to do something like city weather. And this is going to be a list of tuples. So we'll put Pittsburgh inside of here. That's going to be an atom. And then we'll put New York inside here. This is going to be an atom also, but I'm going to put a space inside of it. So I'm going to go and surround that with quotes. And we're just going to throw different temperatures inside of here. Let's go and put Charlotte. Say it's 68. And we'll throw Miami. And we'll say that that is 78. Okay. So then we'll close that off. And then let's say that we want to go in here and we want to find every place that has a temperature over, I don't know, 65. So we can say great temp is equal to, and what we need to do is define city and temperature, which is what we're going to be putting the information into. So there's the pipe and city and temp. And reference the different things that we'd like to work with. And then what we're going to do here is we're going to go city weather, reference that list of tuples, and then we're going to define our condition. We are looking for temperature greater than or equal to 65. Put that inside of there, close that off, and then let's go and see what our results are. So we can just go great temp. And it's going to give us everything that matches up with that condition. And you can see back, Charlotte and Miami pop back. Okay? So there's a whole bunch of different ways or things you can do with list comprehensions. Of course, there's many more. And as this tutorial continues, I'm going to touch on a couple more. But now I want to talk about type conversions very briefly. Okay, so I changed this to type stuff. And basically, you're going to be able to use is followed by all of these different data types to see if what is contained inside the parentheses is actually going to match up with that or not. So we can go like this, and we can execute this to see how this works out. So we'll go tut, and you can see that that comes back as true. And if you did this with all the other individual pieces, you'd see that this is an easy way to figure out what data type any of these different variables would be. You're also going to have a whole bunch more of these guys. You're going to be able to convert basically from one to the other just by using whatever you want to convert from to what you want to convert to. So atom to binary, atom to list, and da-da-da-da-da. And you can see right here is a complete list of all of the different things you will be able to convert to as well as back away from. Okay? And just to show you an example of how we can do this, let's come in here and create list 1 and go integer to list, and then let's throw 21 inside of there, and here we can just go list 1, and if we execute that, you can see the 21 pops back. All right, so I just wanted to show those off here real quick without getting into a bunch of detail. And And now I want to talk about something extremely important in Erlang, which is recursion. Now, recursion is the act of a function calling itself, and basically those things you normally accomplish with looping in other languages, as you're going to see here in a moment, are going to be solved using recursion with Erlang. So let me come in here and just do a simple type of idea here that we normally use whenever we're basically going over recursion and how recursion works. So I'm going to find a factorial. So I'm going to call this find factorial. And what I'm going to pass inside of here is going to be 3. And then let's just go and copy this guy right here. And let's work this out using recursion. So find factorial. Down inside of here then, what I'm going to do, let's go and do it before the find factorial. I'm going to go factorial, and we're going to receive a value. And then what we're going to do is we're going to define a condition here. So I'm going to say when n is a value of 0, what we are going to return in that situation is a 1. Whenever you're dealing with recursion, there always has to be an exit spot, and this is going to handle that situation. Then what we're going to do is actually define the recursive act here. So we're going to say when n is greater than 0, what we're going to do in that situation is we're going to take n and multiply it times, and we're going to call factorial once again, and n minus 1. And if you've never seen this before, I will explain it here in just a second. So now what we're going to do is we're going to go find factorial, and we're going to say, let's go and throw x inside of here, and we're going to say y is equal to factorial and x, and then I'm going to output this on the screen. So I'm going to go fwrite like this, and factorial, throw a new line inside of there, and output the value of y. Alrighty, now let's tab this in again. Now let's run it, and then I'll explain exactly what's going on. And there you can see the factorial comes back as 6. Now basically what happened here is our first run through, as you can see right here, we're getting a value of 3. It's going to say when n is equal to, which would be 3 in this situation, is equal to 0. Well, that doesn't work, so let's just ignore that. Then we come down in this situation. When n is greater than 0, which it is, it's 3 when it's getting passed in. In that situation, we're going to multiply 3 times factorial, and then we're going to call factorial again, and we're going to pass a 2 inside of here. So you can see right here, when we pass the 3 in, it goes 3, and this goes F2. Well, guess what? That F2 is then down here. So what's going to happen? A 2 is coming in, so we're going to go 2 times function of F1. Again, we're going to take F1, which is down here. 1 comes in. We're going to go 1 times F0. What's this going to return? It's going to return a 1. Why? Because of this guy right here, which gives us a value of 1. That's going to be sent up here, placed right there. We're going to multiply 2 times 1, get a value of 2. That's going to go up there. We'll multiply 3 times 2 is equal to 6, and that gives you your final result. Okay, so a simple example of recursion, as I'm guessing you probably have already seen. Let's go in here and do a whole bunch more. Let's go and create another function. This guy is just simply going to be called sum, and it's going to receive a list, and it's going to sum all the values inside of it. So the list this guy is going to receive is just going to be 1, 2, and 3. And then I'm going to go sum and define our conditions. So I'm going to go say if the array is empty, or if the list is empty, I should say. Well, then we're going to return a value of 0, and then we will define our recursive act. Here, we're going to grab the head and the tail, and then as we cycle through the list that's passed inside of here, I'm going to take the head and then add it to whatever sum plus the tail is. And as you can see, it's going to pull the head off of there, then pass the tail. What's it going to do? Pull the head off, pass the tail. And it's going to continue doing that over and over again until there's nothing left in the tail. And then everything will exit, and then we will have the sum of our list values. And if we come in here and we run it, and I'll show you an example if this doesn't quite make sense, and you can see a value of 6 comes back. Well, why is that? Once again, we're calling sum, we're passing in the complete list, which is going to contain 1, 2, and 3. It's going to grab the head in this situation, which is going to be 1, right like that, and then pass 2 and 3 into the sum, which is then going to drop off the 2, which is then going to pass the 3, which is then going to give us 1 plus 2 plus 3 plus sum of nothing, which is going to give us a value of 0. We could just put 0 inside of there if we would be so inclined, and that is how we come back with a final answer of 6. Okay? So another situation in which we're using recursion and to a certain extent list comprehensions. Well, let's go and take another look at this, because we can do something that's called tail recursive. And in this situation, what we're going to do is, instead of holding up the additions like we're doing here, what we're going to do is keep a running count as we run through this guy. So we just have to make a couple little changes here. Up here, let's just change this to, let's just leave it with the name of sum. Here, what we're going to do, though, is instead of just the list, we're also going to have our running tally, which is going to be that guy right there. And what this is going to return when it's all done is the final value of sum. Once again, we're going to do the same thing down here. Let's go and have this be a multi-line function, though, instead. And then let's go and output some information inside here. So let's go IO so we can see the value change as it's being run. So I'll just go sum. And we'll see the changing value of sum as more and more of these guys come through here. And we'll just go sum once again, close that off, and then we're going to be calling sum again. And in this situation, we'll get the tail and the head plus, and we'll add that to our sum. Once again, we can come down here and we can run this guy. And there you can see we got the same answer of 6, just like we did before. Now, Erlang doesn't contain for loops, but you could actually create one. I'll show you how to do it using these same recursive tricks. So in this situation, we're going to have a function. It's going to be called for, and it's going to receive the maximum value we want to count up to and where we're going to start from. Now we'll come down here and define that. So I'm going to go for, and I'm going to go 0. And then I don't care about the next thing that gets passed inside of there. So just put that inside of there. And in this situation, this is just going to return OK. Now it comes time for our for loop. So I'm going to say max and min values we're going to be working with. And then I'm going to say when max is greater than 0. So as long as that condition is true, I'm going to continue doing what I'm doing here in the for loop. So in this situation, I'll go F right. And I'm going to just type out these values as they decrement. So like that. And let's put them on separate lines. And then I can come in and go max once again. And then we can call for once again. And you can see how we're using recursion to basically do what we would normally do in other languages. So max 1 and min, and we can run that guy. And there you can see it decremented those values from 3 to 2 to 1, and then it printed out OK. All right, so there's how we can do a whole bunch of different things with recursion. We're going to do some more with recursion as the tutorial continues. But now I want to take a look at maps. Now a map is a grouping of key-valued pairs. And so let's go and define one. You're just going to say, let's say Bob is the name of this. They start off with a hash symbol. And let's say we want to have the key be first name. Then going to put a little arrow inside of there. And we're going to define that this is Bob. Then we can come in and go, go last name, and put the arrow inside of there again, and have this be Smith. Now we're going to be able to do all kinds of things with it. So we can get the value that is assigned to a key, for example. So we'll just put first name inside of here, and throw in a new line. And how we're going to be able to get that is call maps and get. And what we're looking for, which is the F name, first name for Bob. That's the key for that. And run it. And you can see first name Bob comes back there like we would have guessed. Let's go get a copy of this because we're going to do a whole bunch of these guys. We could get all the keys. So let's just get rid of this here altogether. And to do that, we'll just come in and once again, we're going to have maps, except in this situation, we'll go change that to keys. And then we'll just have this be Bob. And you can see right there, we got all of the keys. We're also going to be able to get all of the values just by changing this from keys into values. And we can execute that again. And there you see, we got our values. We're also going to be able to return everything except the key that we designate that we do not want. And to do that, we can say remove. And we'll put L name inside of here. And Bob's where we're going to be getting the information from again. You can see we got the first name, but not the last name that we designated. We're also going to be able to come in here and check if a key exists by going maps and find and first name and Bob. And you can see it comes back. Yes, indeed, Bob is in there. And we could also come in and put a key value into the map. And to do that, we could just go maps and put, and we'll put address inside of here, and 123 main, and where we want to put it, which is inside of Bob. And we can execute that, and you will see that the address is in there along with the first name and the last name. Okay, so rundown of things we can do with maps. Now let's take a look at records. So I'm going to change this to record stuff and change this to record stuff. Now basically with a record, you're going to be able to define a custom type that's going to contain multiple different fields. And to do this, let's come in here and define a record. So I'm going to go record and customer, and then what I want to have inside of here is the field for name, which is going to have a default nothing. It's going to be empty. And then let's say that they have some sort of balance with our store. Okay, and that's going to be 0 by default. Okay, so there you go. You just defined a record. Now inside of record stuff, let's do stuff with it. So let's go and define a customer. So we'll go Sally is equal to, and we can reference our customer record, and then follow that up by giving or passing in the name. So it's going to be Sally Smith, and then we can define her balance as being equal to, well, let's say she owes us $100. We're also going to be able to come in and change the data. So we could say Sally2 is equal to Sally, and reference the customer again, and change our balance to 50. And then of course we can come and output this information. And we can do this just by going P owes, which is it's going to be her name and how much money she owes us. P, and then we'll put a new line inside of there. And then to pull information out from there, we just go Sally2 and customer and name. And then to get the additional information, we can say Sally2, and once again, customer and balance. And then we can double check that the balance changed, which we know it did. And we run it, and it says Sally Smith owes us $50. Okay? So a real brief example of records. Of course, the whole idea of this tutorial is just to get you accustomed to seeing working examples of how to work with this stuff. And now I want to talk about another important concept, which are higher order functions. Okay, so functions that can receive other functions as a parameter are known as higher order functions. And what we're going to do here is to define a couple. So let's go and define a function that multiplies every item by 2. So we'll call this double, and it receives an x, and so we'll just go x times 2. All right, whoops, there we are, x times 2. And let's go and create another one, and this is going to multiply times 3. So let's call this triple. So triple, and then we'll change that to 3. Now what we want to do is we want to be able to receive a list of numbers and both multiply all of them by 2 and also multiply them times 3. So we're going to call this doMath2. So doMath2. And then we'll come in on here and define how it's going to work. So we'll go doMath2, and then I'm going to go list and map. Now map is going to take a function and then apply that function to every item inside of a list. And to do so, we're going to use something called fun, which is going to be used to assign a function to a variable. So we'll go list and map and fun and double, which is the guy we define right here. And how many attributes does it get? It gets 1, so we're going to put that inside of there. And then we're going to define our list right like that. Now what we can do is come in and also call the triple function. So we'll come in, paste that inside of there, and this is triple instead. And we'll just have the same exact list passed inside of there, and we can store that up, and we can come in and we can run it. And you can see that it gave us 369. And of course, if we got rid of this guy and save that like that, we could then come in and run that guy and just double those values. Okay, so that's an example of a higher order function, but we're going to do some more stuff here. Let's also come in, and I'm going to create another function inside of here. And this is going to be called fun stuff, just so you can see more examples of how we're going to use this. And what this is going to do is pass my name inside of there. And you're actually going to be able to use fun to define anonymous functions. So we're going to go and define fun stuff. It's going to receive something. And then I'm going to go fun stuff equal to fun. and I'm going to output some information on the screen. So fwrite, and what this is going to do is just go hello, and whatever the name is, it's going to pass that out on the screen. So we go like this and like that, and then at the end of it, we'll just put end and a comma, and then after that, we can say fun stuff. Okay, so save that up and run it, and you can see hello Derek pops back. All right, something else that's interesting. Let's go and do fun stuff 2, and let's just have it do nothing. You're also going to be able to access values that are outside of your function. So let's just change this to fun stuff 2 like that. Get rid of this guy right there. Get rid of all this stuff right there. And then we're going to go x is equal to 3. And then y is equal to 4. And then z is going to be equal to, and here is our function, and it's going to be able to access all of those values outside of the function. What we're going to do is go fwrite, and we'll go sum tilde p, new line, and we'll be able to go x plus y, call end on that, and then bounce down here and call the z function. And if we run it, you can see that the sum comes back as 7. Okay, so a couple neat little examples there. Now I want to take a look at file I/O. Now I'm going to create a function that is going to be called write text, and it's going to pass in a string called write to the file. And then let's come down here and define this function. So we'll go write text. It's going to receive a string that's going to write to a file. What we want to do here is get a file handler that we're going to use to write to our file. How you do that is you go OK and file handler. And then we're going to say file. What do we want to do here before we want to write to it? Well, we want to open it. So open or create it if it doesn't exist already. So there is our text file. And then we need to define what we're doing. Well, we're writing or overwriting what might already be there. Then what we need to do is write this text to our file that we have open. So there that is, file handler and new. And then we're going to close off that function. Well, we'd also like to probably be able to come in here and append data to it. So let's go and create another one of these, throw that inside of there. We'll call this write text to, and that just means it's not going to overwrite. And to not overwrite, but instead to append data to it, we're going to type append in there, and we're going to leave write be exactly the same. And let's go and call write text to once again. So we'll copy that out of there, paste that in there, write text to. And then we'll just do something like more text to the file. And what's the point of writing all this information if we can't read it? So we're going to create another function that's going to be called read text. And first thing we have to do is get read permission on this. So we go OK, and the file that we're working with, and go file, open. And what are we going to do? Well, we're going to go and get my file out of this guy. So let's just get this, paste that there. But what are we doing this time? We're reading, so we have to put read inside of there. And then we just need to read the text and store it inside of a string. So there's words, and then to get the text out of the file, we just go read, and then you're gonna put file inside of there, and 124 times 124 to find the size of that information, and we're gonna go fwrite. And let's output the information that we want to, or that we have stored in the file. Do that, like that, just like we always have been doing. And then we'll just reference words. And of course, we need to call the read text up here. So we'll go read text, and then we'll see all this stuff work. So tut main, whoops, and I had a little error in there. I got to get rid of that period, put a colon inside of there instead. And likewise, change that period right there to a colon as well. And don't forget to put your little comma up here. See, little things like that will totally slip you up. All right, and we'll run main. And there you can see, write to the file, more text to the file. Okay, so we wrote to the file and we went and read from the file. So that's how we do file I/O. Now let's take a look at exception handling. Now, basically, exception handling, like I'm sure you know, it's just going to allow our program to handle errors rather than just crashing. And I'm just going to provide a very simple example you'll be able to expound upon from this point. I'll go and do 2 examples, actually. I'm going to call a function that's going to be called error stuff, and it's going to pass in a value of 0. We're going to try to do a division by 0. All right, so what we're going to do here inside of error stuff anyway, is we're of course going to receive parameter or an attribute inside of here. Now where you think an error may occur, you're going to put a try, and then you're going to put the code that could cause an error inside of there. So what we're going to do is we're going to take 2 and divide it by whatever they passed inside of here. And if they passed in something good, we will then provide the answer. Otherwise, we're going to then come down here and define catch, and we're going to list the error that we are looking to catch. So that is going to be a bad arithmetic error. And then after here, we can list what the error is. Can't divide by 0. And then after we're done, we can go end. Okay? And if we run it, you're going to see what it does. Can't divide by 0 comes back. And if they would pass something inside of here that actually does make sense, let's say they throw a 4 inside of there. In that situation, it'll just do it and not throw the error, of course. Let's do another one. Let's say you wanted to do a catch-all with this guy. Let's go and say we wanted to do, let's do file IO because we just did that. We'll go read text2, and then we're going to go and define that here. So we'll go read text2, throw it inside of a try block. And then inside of here, we're going to try to read a file just like we did previously. In this situation, though, instead of my file, I'm going to call for my file 1, which doesn't exist. And what I want to do is I want to catch any error that could potentially occur with trying to read the file. And in this situation, trying to read a file that doesn't exist. So to catch everything that could potentially go wrong, we'll put an underscore, a colon, and an underscore. And that's going to catch all errors. And we know that more than likely, if we're trying to open a file for reading and we get an error, that means the file doesn't exist. So in that situation, I'm just going to say file doesn't exist. If indeed the file doesn't exist. And then we'll come out of here and type in end. And we'll run it again. And there you can see file doesn't exist pops in. All right, so cool stuff. Or, you know, of course, we could change that to my file like we did before. Dot and main and da. And you can see that it comes and writes or reads it. Okay, so cool stuff. Now I'd like to talk about macros. Now, macros provide for inline code replacement, and it's probably better just to see an example here to see exactly how that works. So what I'm going to do is I'm going to define the macro, which is going to be x or add, and then it's going to get 2 parameters passed inside of it, x and y. And then afterwards, I'm going to define exactly what's going to happen with x and y inside of this. Okay, so now what we're going to be able to do, well, let's go up here and let's define macro stuff like that. And then let's go and create macro stuff. So macro stuff, and this is going to receive x and y. And then what we need to do here is to use our macro. So we're going to go f, right, okay, tilde p, and a new line inside of here. And then to call for our macro, we're going to put a question mark inside of there, and then add and x and y. Now, you normally want to do something this simple with a macro, but, you know, I'm just using this as an example. So you can have this be much more complicated, okay? Now for macro stuff, come up here and do 5 and 6 in there, and then we'll come down here and run this guy, and you can see that 11 comes back. All right, so real brief example of macros, just wanted to definitely cover that. And now I'm going to provide you with some simple examples on concurrency. Okay, so concurrency is when several processes are going to execute at the same time and potentially interact. And as long as the processes aren't dependent on each other, they can run at the same time. So for example, if you had one process that its only purpose was to count to 1 million and another that's purpose was to calculate pi, these are going to be things or processes that are not dependent. If, on the other hand, you had one process that's job was to start an engine and another process that was had the job of driving a car, well, obviously they're dependent. You have to start the engine before you can drive the car. So what I'm going to do here is just give you a very, very simple example here, and this should get you going to learning more about concurrency. So I'm going to have the get ID and fwrite, and let's see what I'm going to do with this. Maybe this will work, maybe it won't, I don't know. Am I gonna, yeah, I'll call it. All right, so each process is gonna have an ID, and let's go and pull this out of here, and let's be M. So the whole point of this is just to get the ID of the process and output it. So I'm gonna create a function called spawner. And what this guy's going to do is spawn a process, and the process in this situation is going to call for get ID to run. So we're going to define that. So get ID. And then self is going to give us our ID, if I spell it properly. So self. And then you're going to put end at the end of that. And then up inside of here, what I'm going to do is I'm going to call spawner a couple times. So you go spawner and spawner. Why don't I go call it 3 times just so you can see it. All right, and spawner. And you're going to see that there is going to be 3 processes running. And there you can see are those 3 processes, okay? So really, really simple. Let's go and do something a little bit more complicated. You might remember this guy from before. This is our for loop. And what I want to do is I want to take this code and I want to start 2 different processes and have them count in different directions. Okay, so we got that guy. And we're going to call this spawner2 just to change the name of this. Get that like that, and you'll be able to see now how these processes take turns and execute code. So I'm going to go spawner2, and we're going to have a max value and a minimum value passed inside of it, and then they're just going to execute. So we're just like before, we're going to go spawn, and we're going to define what we want to happen here. So we're going to go for2, and it's going to get a max and a min value and end. And how these are going to differ is going to be based off of the information that's passed inside. So this guy right here is going to be counting down from 50 to 1, while this guy right here is going to be counting down, well, from 100 to 51. Okay, so a little bit different. And when I run it, you'll be able to see how they trade places back and forth. And oh, change this to 4.2. Got a little bit of an error there. Not a big deal. Save that. All right, and come over here and run it. And And there you can see they're counting their way through. And after they are all finished trading places and counting and counting and counting, we can cycle up through here and see exactly what was going on. So here we are back at the very, very beginning. There we are. And you can see 50, 100, 49, 99, 48, 98, 47, 97, and so forth and so on. So they execute those 2 processes and they basically take turns spitting out the results or performing the actions that I told them I wanted them to. Alrighty, so there you go, guys. That is a rundown of a lot of things you can do with Erlang, and hopefully it's sort of cleared up how to accomplish things using Erlang that you can already do in other different languages. And like always, please leave your questions and comments below. Otherwise, till next time.